Hello everyone, how are you doing? I'm sure all of you are fine, and as I promised you, I'm gonna take another lesson on age prediction from image using ResNet 50. So this is really going to be a very interesting lesson. So in this lesson, what I'll be talking about, I'll be first talking about what is ResNet 50, and this is actually a CNN model, all right, and to this notebook, and if you are creating this notebook from the new notebook, then do remember you need to set your runtime there, runtime to GPU, otherwise it will not produce. It will take a lot of the time to train. So you should select their GPU, and apart from that, everything is fine. Let's go ahead and toggle this header. Alright, so we'll first talk about the ResNet, and then I'll also talk about the ImageNet model comparison, and then I'll talk about the Ktrain, the Python package, which we will be using here to wrap our TensorFlow and the Keras APIs. And then you can get the whole dataset from my GitHub repository, and the original dataset is available here. And apart from that, then after this training and the testing this dataset, I'll be showing you how you can predict. So there, this image here, in this image, it says that the actual age is 26 here, and it has predicted here 29 years. All right. And apart from that, I will also show you here a real-time image capture and real-time real-time age prediction. So what I did here, I had captured my image here, and I'm around 29 and 30-year-old, and it has predicted my age 28 years old. I'm pretty much happy with the 28-year-old, so I wish at least 2 years I have gained here. All right. So this lesson is really gonna be very interesting, and apart from that, I'll also show you how you can save your model for offline prediction. So you can download it on your local computer, and then you can use this trained model directly for your prediction instead of doing the training and then prediction. All right, perfect. So without wasting time, let's go ahead and get started with this lesson. All right. Now let's go ahead and get started with ResNet. And in this lesson, we are going to use ResNet 50. Let's go ahead first understand what is ResNet. ResNet stands for Residual Networks, and it is a classical neural network used as a backbone for many computer vision tasks. It was winner of ImageNet Challenge in 2015. Basically, this ResNet 50 is made by Google, and it was actually a breakthrough in the ImageNet, and with this ResNet 50, it has successfully trained more than 150 layers. Before this, it was not possible to train this much of layers because of the vanishing gradients. And if you understand here, this is the architecture of ResNet 50. It has total, these you see, there are total 1, 2, 3, 4, and then I think we should have a 5 there. So 1, 2, 3, 4, and 5. So these are the 5 convolutional layer. So this is the kind of, you can understand, this is the ResNet architecture. All right. And if you want to compare this ResNet with other ImageNet model, then there you will see the ResNet stands somewhere here. This is ResNet 50. So this ResNet 50 is somewhere close to Inception version 3 in the term of the accuracy, as well as ResNet 101. Although there is around 2% of the accuracy difference, but the number of parameters are really very small as comparison to the Inception version 3 or Inception version 4 or other parameter. So there you see, this is the parameters, how many parameters or how many multiplications operations are going on there, and this says that how much the accuracy we are getting. So basically we look something somewhere here, but ideally we don't get anything here, but the mostly we try to we try high accuracy with less number of operations. And in this regard, what we get here, as comparatively with the Inception version 3 or VGG 16 or 19 or ResNet 152 networks, we found out that ResNet 50 is somewhere pretty much good in the term of less number of operations as well as the accuracy. Alright, perfect. So we'll be using this ResNet 50 for the prediction of our predictions of age on the given images. And we will be using here a TensorFlow 2 Keras, and basically this will be wrapped under the Ktrain package. So this Ktrain, you can get more information about Ktrain at this GitHub repository, and if you have seen my previous videos, I have described this Ktrain in very details. So the Ktrain is a library which helps to build and train networks faster, and it uses in the backend TensorFlow 2 and the Keras. So you can see that this Ktrain is kind of wrapper library on the Keras, and you know the Keras is wrapper library on the TensorFlow. So with this Ktrain, what happens? The neural networks or image processing or the NLP task has become really very simple. You don't need to worry about much on the data preparations and the processing. All those things are being automatically handled by this Ktrain. So the Ktrain uses TensorFlow.Keras in TensorFlow instead of standalone Keras, and it is inspired by the FastAI library. There are so many the advantages of using a Ktrain, like it can optimally find out the learning rate, and then it can use various type of already the pre-trained image networks like ResNet, wide residual networks, Inceptions, and then it can also load and process text and the image data from a variety of formats. So all those things can be done very quickly with the Ktrain. Alright, so I'll be showing all those things here, and the data set on which we are going to work in this lesson, you can directly get it from my GitHub repository. So these links will be in a video description. You can get it from Lakshmi Merit image dataset for age prediction, and the original dataset is at this address, but this dataset was in the lot of the zip files, so that was not convenient to the work with the fast process. So what I did, I downloaded dataset from this website, and then I did some pre-processing. That's mean putting all the images in a single folder, and then I uploaded it on the GitHub, and now you can directly download it from the GitHub instead of downloading from this website and then putting all the images together. So these things I have made simple. Alright, so we'll be using this link for a cloning purpose. Let's go ahead and copy it. First of all, we are going to clone this data. Alright, so what I'm going to do here, I'm going to type there git clone, alright, .git, alright, sorry. So that's the .git. So it will clone this repository here. So this repository is kind of 1.5 gigabytes. So this is very large repository. It might take some time to download, but while it is downloading, let's go ahead and install there our Ktrain. All right. So the Ktrain, you can install it with the pip install Ktrain. All right. Perfect. So there you have a pip install Ktrain. Alright, perfect. So once it is downloaded, then it will start installing a Ktrain. While it starts installing a Ktrain, in meantime, what we can do, we can also write some code for importing necessary packages. So the necessary packages which we will be using in this lesson, those are matplotlib inline, because we will be also plotting some images in this lesson, and then we need their import OS, and then we also need here import Ktrain, and apart from that we also need here from Ktrain, import vision. All right, so we are gonna import this vision as which. All right, perfect. So we have written these necessary codes. What we need to do now, we have to wait for some time so that this data is downloaded and this Ktrain is installed. So I'm gonna stop this video for some time, and I'll connect you once all these things have done. Alright, so Ktrain is successfully installed and the data is downloaded, and you can see this data set here. Image dataset for age prediction is downloaded here. Alright, now after this what you can do here, let me close it. Alright, so let's go ahead and run it. Once you run it, well, after running it, now we need to actually find out the ages from the image dataset. That's mean what is I'm going to do here. Let me first show you an example here. What happens here? Let's say here I have a lot of the images, although it might take some time to display all those images, and if it is not available from there, because it's a Jupyter notebook, so it might take a lot of the time. So what I'm gonna do here, I'm gonna close it here, and then I'm gonna show you from my GitHub repository itself. So just wait a second here. You can click on here. All right, so it will open it as my GitHub repository. In the image, just wait a second. Okay, so it seems that it has just hanged. Okay, so in this images, I have a lot of the images. So what happens here? So these there is numbers after and then underscore 0 underscore 0. So what happens here? This 100, this is actually a age. All right. So before this underscore, this number says that this is a age, and there you see this is 100. All right. So this clearly says that this guy is 100-year-old. And similarly, you can also see the other images as well. So this first number says that age. All right, for this, let's say this is the 10. That's mean this will be for a child. So this guy is a 10-year-old. All right, perfect. So our task is to get the age from all these images, and that age is, this is the first digit, I mean these numerical digit before the underscore. So what I'm going to do here, I'm going to first write here, and I think it has again hanged a little, so I need to wait a little time. Well, it was hanged for some time, now it's okay. All right, perfect. So let's go ahead and run it. Once we run it, it will import the matplotlib inline OS Ktrain and vision package from a Ktrain. Now our task is to get that age from the image. So how we can get that age from the image? We need to make here a regular expression. So in the regular expression, I'm gonna first create here a pattern, and that pattern I'm gonna create it with this regular expression. So there I'm gonna say that square bracket. Inside a square bracket, if I put there a caret sign, so it says that neglect, or okay, so neglect just the anything actually. Okay, so this neglect this forward slash and capture anything other than this forward slash. I'm gonna put there a plus sign. All right, and after that I'm gonna say that the underscore. So with this, what happens? So there it will get that before the underscore. All right, all these age values. To make it a little more clear, let me again open any image, then I'll show you. let's say this one. All right, so I want to get this 10. All right, so there is 1 underscore, then 0 0. All right, and then this is the date time. All right, so this is also male and the female. For a male it is 0, and for a female it is 1 actually, and then there is the ethnicity. All right, so but we need only this one. All right, after that we need to put there 1 2 and 3 underscore and 3 digits. All right, 3 numbers. So what I'm gonna do here, 1 underscore, then there is a digit d plus, then again there is underscore forward slash d plus, again underscore forward slash d plus. So this says that these are the digits, and this is the gender, male or the female. Then there is ethnicity, and then we have here the date and time. And after this date and the time, we have .jpg. All right, so that's the format, and then the end of string there. All right, so that's the end of file. So this is the pattern, and this pattern we can get it with the import re. That's the import regular expression. Then I'm going to create here pattern re dot compile. All right, so with this compile I'm going to pass this pattern inside this compile. Then I'm going to say that r is equal to p dot search. All right, and for the testing purpose, what I'm going to do here, I'm going to just give the name of that file. All right, so the name of that file is, let's say, this one, so that it should actually let me get it this whole file name. So it should actually give you 10 in the result. All right, so I'm going to search it on this one, and then I'm going to see what is going to be a final output. All right, so print here. So I'm going to print r here. All right, let's go ahead and run it. Once I run it, it might take a little time, but it says that there is 0 to 20. So what I'm going to do here, I'm going to group it. All right, so there's the group. All right, and then the group 1. So with this group 1, what I get here, I get this 10. So that is the age of this the person. All right, so this is the regular expression. So with this pattern we get their image, and then their age in the label as well. All right, so the things are clear as of now. Okay, all right, now let's go ahead again, see our dataset folder here. So this is the dataset folder. Inside this we have images folder. All right, so we are going to take the path of this images folder, and then I'm going to paste it here, just so that I can see it clearly. All right, so that's actually our data dir. That's the dataset directory. That's the dataset dir. All right, and now we have our dataset dir. Now I'm going to use here a Ktrain. So in the Ktrain, I'm going to use here a vision package. So I have a which dot, then images. So there we have images from file name folder. So what we want, images from file names. All right, and then I'm going to also pass here the data directory. That's the data dir. Let me put it here. So there I have a data dir, and then I'm going to pass here the pattern. So this pattern will result the label. All right, so the pattern is pattern which we had earlier, and after this I'm going to say that here, if you see, there is another parameter, is regression. So is regression says that is it a classification task or a regression task. We are going to predict here age of a person from a photo. That means this is a regression task. For example, if I say that 1, 2, 3, 4, 5 in classification task, 1, 2, 3, 4, 5 are independent, but in the regression task 5 is more than 4 and 4 is greater than 3 and so on. All right, so I'm going to say that here each underscore regression. All right, so I'm going to say that each regression is equal to true here, and then I'm going to say that here random underscore state. The random state I'm going to put here 42. All right, so any random state you can choose, not a problem. So with this we get our images. Now what I'm going to do here, this returns actually the 3 variables. Those 3 variables are the training set, validation set, and then preprocessor parameter. So it has a train underscore data and then test underscore data, and there it has preprocess. That's the preproc. I'm gonna say that. So this is a tuple actually. All right, let's go ahead, run it. Once you run it, it says that it has found 21,669 validated images. All right, and yes, total I think it has found around the 23 or 24,000. So the few images could not be extracted because of the wrong file names. That could be the case. That is why it could not be, because you see there were the 3 underscore, but in all these images there is only the 2 underscore 2 2, and there is a double underscore, and perhaps there is a space in between this dot jpg. So that is why these images got skipped. All right, anyway, so we have got our the train data and test data. Now what we are going to do here, we are going to print all those classifiers which are available for the actually the regressor, image regressor, which are available to use for our purpose. So the currently we have ResNet 50, MobileNet, Inception version 3, and we have also wide residual networks. So we are going to use here ResNet 50. Let's go ahead and copy it. Then I'm going to say here model is equal to vis dot image underscore regression model. All right, and there I'm going to say that pre-trained ResNet 50, and the training data which I'm going to pass here a train data, that is a train data. All right, so this train data, let me stop it. That's the train data we have got here, and the test data as well. All right, and apart from this, I'm also gonna pass here a validation data. So let me put it on the new line so that you can see it very clearly. All right, so there I'm also gonna use here a val underscore data. So this is the validation data. In validation data we have here a test underscore data. All right, so we had train data and test data. Let's go ahead and run it. What it will do, it will first analyze these data, and then it will also download actually pre-trained ResNet 50 from the internet. So the first of all it will download it, and then it will check that is it a multi-label classification or a multi-class classification or a regression. So it says that this is a regression problem. In the regression problem, all the labels or target labels are numerically actually dependent. That means it's kind of on a number system. 1, 2, 3, 4, 5 will be greater than or less than the numbers of their conjunctive. The previous are the after the numbers. All right. So this pre-trained ResNet model is created here. Now what I'm going to do here, I'm going to wrap this model with the learner here. So I'm going to say here learner is equal to Ktrain dot get underscore learner, and yes, so that's the learner. In this learner I'm going to say that model is equal to model. So that model is actually the model which we had passed passed, and that was ResNet 50. And then here again we have a train underscore data is equal to train underscore data, and then again we have here a validation data that we have here again. That's actually the test data instead of validation data, so that's the test underscore data. And after this I'm gonna use here a the batch size actually. So there I have a batch underscore size. The batch size I'm gonna use here a 64. Alright, so with this we have got here a learner, and once we have got a learner, now we need to select here a learning rate. So the learning rate by default, which I'm gonna select here, is the 10 power minus 4. Why the 10 power minus 4? Because I had tested that in the offline that 10 power minus 4 best suited for this application. So finding a learning rate takes a lot of the time. So that is why I'm gonna skip that. So for this purpose, you can directly select this 10 power minus 4 learning rate. All right, perfect. So what I'm gonna do here, I'm gonna say that learner dot fit underscore 1 cycle. All right, so in this fit 1 cycle, what I'm gonna use here, I'm gonna first use a learning rate. So the learning rate I'm gonna use here 10 power minus 4, and after that I'm also gonna use here how many epochs I want to run it, for how many epochs. So currently I want to run it for 2 epochs, and do remember here I'm not gonna freeze any layers of this ResNet model. All right, so whatever the weights of this ResNet model, I'm gonna use those the weight pre-trained ResNet model, and then I'm gonna fit it on this my data. And do remember that is just for 2 epoch, and after that I'll freeze some layers of ResNet so that I can keep the originality and pre-trained weights of the ResNet, and then I'll be only training last few layers of the ResNet. So let's go ahead and run it. So it will train it for 2 epochs. So this 2 epoch might take some time, so we need to wait for some time so that it can complete this the training for 2 epoch. Alright, so while it is a training, for the sake of the time saving, what I'm gonna do here, I'm gonna write here the few more lines so that we can save some time instead of waiting to train it and then writing that again. So let it be the next line which I'm gonna do here, as I told you that I need to first learner, this should be actually learner, I need to first freeze some layers of ResNet. So what I'm going to do here, learner dot freeze, so it will freeze first 15. All right, so it will the freeze first 15 layer of ResNet. That's mean once this training is done, after that it will freeze first 15 layer of ResNet, and after that another 35 layer will not be freezed. That will be unfreeze. That will be actually will not be frozen. So let's go ahead and after freezing first 15 layer of ResNet 50 the pre-trained model, then again we need to actually run it for 2 more epochs. So I'm just gonna copy it and then paste it here. So what happens here, it will first run for 2 epochs in this one, and after that I'll freeze first 15 layers, and then I'll again train last 35 layers with 2 more epochs. Let's go ahead, run it. So what will happen after running this cell, it will start running this cell. Now finally we are going to wait some time so that once this training is complete, then we are done with the training process, then we will directly start on the prediction. So we'll test our model and then I'll show you some real pictures predictions, and then it will be predicting the age from that picture. All right, so let's go ahead, wait for some time. All right, so you see there, the first part is already trained, that is for 2 epoch. And after that, I had frozen first 15 layers of ResNet 50. And after that, I'm again gonna train last 35 layers with 2 more epoch. So in those 2 more epoch, 1 epoch is already trained, and this is the last epoch. This is a last epoch which is being trained. So around 3 minutes and 30 seconds time is left here. So while it is training, what I'm gonna do here, I'm gonna first write here. For a prediction. All right, so I'm gonna write some code for the prediction so that we can save some time while it is training. We can write a code to make a prediction. How we can get a prediction or a predictor? If you have seen my previous videos, there I have described that predictor is, so there is a predictor. Predictor is equal to Ktrain dot get underscore predictor. All right, so with this what happened, we get a predictor from a model and pre-process. So there a model we can get with learner dot model and then comma pre-process. So this pre-process, I need to get it with the right spelling actually. At one time I had a mistake and then I was searching what was the wrong here. Let me get where is that pre-process, and that is here. All right, so this is a pre-proc. All right, perfect. So that pre-proc is here. So with this we get here a predictor, and once we got the predictor, after that what I'm gonna do here, I'm gonna first get the few validation images, so that I can get with actually a test underscore data dot file names, and in that I'm gonna take here 10 to 20. That's mean this is a random selection with 10 to 20 file names. So it will give us the 10 file names from the test data set. All right, once we get the 10 file names from the test data set, then we need to make the prediction. See here, this is almost gonna finish, so just 1 minute. Okay, hold on 1 minute. In the meantime, what we can do, we can keep writing some more code so that we can save some time. All right, so here we have a def. Now let's say suppose that we got here a predictor and then the test data. Now what I'm gonna do here, I'm gonna do here def show underscore prediction. All right, so that's the show underscore prediction, and then I'm gonna pass their file name. So that's the f name actually. All right, once you do this, all right, so after this what you get here, f name is equal to, we have data dir. Do you remember the data dir? That's the directory of the data. All right, so there you have the directory of the data. All right, so it seems it is almost finished. So what we can do, we can just wait for a second so that it can finish it. Anyway, so in meantime, let's go ahead, write it, data dir plus a forward slash, then the plus sign here. And with this, what we get here, that's the f name, that's the file name. So we get there a file name. All right, why this file name is important with the data dir? Because the data dir is this image data set, age prediction, and then images, and inside this validation test set there is just file name. All right, so it is trained. Let's go ahead, run it. We get here a predictor, and after that it will make a clear here. So these are the file names. All right, so with these file names, what you get here with these file name? So with these file name, these are actually located inside the data dir and then the file name. So that is why I did this. All right, and then I'm gonna do here prediction. Pred is equal to round. Then we have here again predictor. So that's our predictor here. We have got this predictor. Once we get our predictor dot predict, so dot predict, all right, underscore file name. All right, so what it is gonna do here, it is gonna predict actually here a file name. All right, so there we predict a file name. All right, perfect. And then here we have here a 0. Why it is gonna predict a file name? Because we had loaded our images from the files. So this is the beauty of this Ktrain. So it works in many ways, and it really made all those things very easy. So images from a file name, and this information is saved here in the pre-process, and that is what here I had the past that pre-process here in the predictor. All right, so there it predicts here a file name, and then after that what I'm gonna get here, the actual age from this file name. So let's say if we predict age for this file name, then actual age is 28. So this is the same way as we did earlier. So here we have int. Earlier it was getting like a float. We are going to change it as int p dot search. If you remember, then we are gonna pass here a file name. All right, and then we are gonna pass here a group 1. So with this we get the actual age from any given file, and once we get that, now I'm gonna visualize the image which actually we are dealing with. All right, so that's the file name, and then finally I'm gonna print it here. So what I'm gonna print it here, I'm gonna print it here predicted age. All right, so that's the %s here, and after that here I have actual age. All right, so that's the %s. That's mean it is a string which we are gonna deal with, which we are actually gonna deal. All right, so once you have this, then there is a % again, then there is gonna be here a tuple, then there is pred, that's the predicted, and then we have here actual. All right, so the most of the part is already done here. Let's go ahead and run it. Once we run it, then we can now call our show prediction. So let's go ahead, call this show prediction, and in this show prediction I'm gonna pass some randomly. Let's say I'm gonna pass here this one. All right, so once we pass this file name, then we will get here a real image, and that's the age. So the actual age of this guy is 26 year, but the predicted age is 22 year. So it happens because we had taken less number of the data, and we did not do actually a lot of the transformation in the image to deal with the multiple, multiple type of the images, as well as we had trained it for the less number of cycles. Now let's go ahead and get the prediction for this one. So we can get it for this one, and there we have here. All right, so it says that actual is 27, but the predicted is 31. And similarly, let's go ahead, get it this one. All right, I think I'm gonna get it actually this one. Okay, all right, so there what I'm gonna do here, I'm gonna get it here, and then you see it's 26 and the 29. So what is happening here? It is just 2 or 3 years of the difference, and it is predicting the age pretty much correctly. So this is how it is doing for the images which is already in the validation data set. Now let's go ahead and see how you can do it with the real time images. So the real images, all right, so to deal with the real images, what I'm going to do here, I'm going to click my picture, and then I'll show you what is the my age. So currently my age is 29 and the 30. So let's see what it is going to predict. All right, so I'm going to click on the camera capture. On this camera capture, what it says that in the camera capture it has this code actually. So this is the code. What I'm going to do here, I'm going to insert it. So once I insert it, you will see there it automatically insert all that camera capture code here. All right, so you get these code. So what I'm going to do here, I'm going to run it. Once you run it, and then I run it here, then you will see here it opens my webcam. Now you can see me. Hi guys, how are you doing? So I'm sure you are enjoying it, and I'm sorry the previous at the behind me the things are not pretty much well. So it happened because I had to put those things because recently I had changed my flat, and the voice echo was occurring in this room. So I had to remove the sound echo to put all those stuffs behind me, because the sounds was going backward from my front wall to backward wall and then coming back here. So basically what was happening here, it was echoing the back and the forward like this. So there were a lot of the echo was occurring. Anyway, so let's go ahead. So what I'm going to do here, I'm going to capture this. So how you can get this capture? So you see there, this is the capture. So with this capture, I'm going to capture my image, and then I'm going to see that what is my age with according to this algorithm. All right, so I clicked on this capture. So this saved my photo in the form of photo.jpg. So what I'm going to do here, I'm going to see it here. All right, and there you see it has a photo.jpg. all right, perfect. So now what I'm going to do here, I'm going to again copy it, and I think I need to copy it because you see there this function was made for the prediction from a data directory, but actually we don't need prediction from the data directory, we need directly from the root file. So I'm going to copy and paste it here, and then I'm going to change it to here a real prediction. So with this real prediction, of course I don't need this one, and then I also don't need this one as well, and apart from that I of course don't need this actual, and all right. So this is pretty much code which we are going to deal with. So I'm going to write here real underscore prediction, and there I'm going to pass the name of the photo which we had just clicked. This is photo.jpg. So the photo.jpg, let's go ahead and run it, and it says that I am a 23-year-old. So there is around you can say the 6 years of the difference. This could be because of the lightning perhaps. I'm not sure why it has happened, but it should have actually predicted around the 26 or 27. Earlier I had tested, it was predicting somewhere around 27 and 28 years old. Anyway, so what I'm going to do here, I'm going to again capture my photo, and with the more better frame. All right, so what I'm going to do here, I'm going to come a little near to the camera. All right, and then I'm going to capture it, and then let's go ahead and see what is my age. All right, although all those things should not happen because because in the real practice you deal with the different kind of the images, and you can actually improve these things by including more images, because this Google Colab notebook have a very limited RAM, so only we can use around 25,000 to 30,000 images, and after that memory overload may occur. So if you have a high GPU at your home, then definitely you can try with a more number of images. All right, so what I'm gonna do here, I'm gonna again, since that photo got updated, I'm gonna again run it with the new photo. Now it has predicted here 18-year-old. All right, so what happening here actually, so perhaps because of this night light, my photo might not be able to come clear, so that is why it is happening. Anyway, so this is how you can do. And apart from that, if you want to save this image, all right, if you want to save it, I'm not satisfied with this one, so what I'm gonna do here, I'm gonna again run it, and then I'm gonna capture here without speaking. All right, so only these type of the images were actually present. All right, so that's why there is happy faces there. All right, let's go ahead, run it. Now you see there is 28 years. So wow, that's beauty. All right, perfect. So what I'm gonna do here now, we are gonna save our let's say if you want to save this this trained model for later use, then how you can do it. So this is also really simple. You can use like predictor dot save, and then you can pass where we want to save. Since we are working with the Colab notebook, then we can actually, we need to write here a content. So this is the root directory, and then I'm going to write here age prediction. So it will save here inside here age prediction. All right, so let's go ahead and refresh it. You should see here. Well, I'm not able to see it. Okay, so that should be actually the content. All right, so we should be able to see it here. Let's refresh it. There is age prediction. So in this age prediction, we have here our TensorFlow model, which is around 300 megabyte, and then here we have TensorFlow, the pre-process model. You can download it by here, but it will download here individual files. But if you try to download this complete folder, you won't see any download option. So what we need to do here, we need to zip this age prediction. So once we create here a zip file, then we will be able to download all the files together. I mean, all full folder together. So exclamation mark zip or recursive zipping, that's mean zip all the content from the files. That's the content in the file, actually content age underscore prediction. All right, you can say that the predictor actually dot zip. So I'm gonna zip it inside the age predictor, and then I'm gonna take it from, I mean, I need to put here a source file. It is inside the content, and then age underscore predictor. All right, let's go ahead and run it. Once you run it, you will see here it says that there is a zip error. Let me see, age underscore prediction. Oh, sorry. So that's actually age underscore prediction. So that should be age underscore prediction. All right, then you should see here age underscore predictor dot zip. All right, so it might take a little time. Just wait for a few seconds, then you will see it. It is taking a little time. All right, so it has started zipping it. Yes, it is finished. Then refresh it, and there you have here age predictor dot zip. All right, perfect. Now you can download it here, and once you click on the download, it might take some time because this is a large file, so it might take some time to complete its download. All right, perfect. So this is all about in this lesson. Thanks for watching, and I'm sure you have enjoyed this lesson, and please do subscribe and like this video to support us. Bye bye, have a nice day.